Hi, everyone. Thank you for joining us for today's session about Microsoft's internal DevOps processes, where we will discuss the ins and outs of how DevOps are managed at Microsoft and see which procedures and tools help maintain quality across its entire dev test pipeline. Our expert speakers are Abel Wang from Microsoft, Principal Cloud Advocate specializing in DevOps and Azure with a background in application development, and Eran Bar-Lev from Applitools, Senior Software Engineer and ISTQB Certified Software Tester. So without any further ado, Abel, the stage is yours.
Thank you so much. I am so excited today to talk to you guys about quality in the DevOps world. Now, before we begin, though, let me do a quick intro for those that don't know me. My name is Abel Wang. I'm a Principal Cloud Advocate that specializes in DevOps. However, my big claim to fame really is I am a coder. I have been writing code for over 20 years. I eat, drink, and live writing code, right? That's what makes me really happy. So just to give you guys kind of some background, I'm that weird guy at Microsoft where after a really long, hard day of writing code at work, I go home, right? I play with my dog, talk to my wife, we make dinner together, then we kick back and watch some TV, right, to relax. And that's when I pull out my laptop and then I start writing more code because that's what makes me happy, right? So currently I'm on a team, I'm on Donovan Brown's team, and we are 5 DevOps practitioners, and our sole purpose is to help enable everyone to get into Azure using DevOps best practices. Now notice I didn't say using any specific tool set, because really it doesn't matter. But we are here to help people use DevOps best practices to get their code into production. And hopefully production means Azure, because I am from Microsoft, of course. But we are here to help you guys. We are super, super active on Twitter, right? So if you have any questions, please tweet at us. Go ahead and use the hashtag LOECDA. That literally lights up a team room for us. And we will see those questions, we will answer those questions, and if we can't answer it, we will find the right people at Microsoft that can answer those questions for you. So please follow me on Twitter at AbelSquidhead. You can tweet questions directly to me or tweet it to my team using the hashtag LOCDA. All right, so let's go ahead and talk a little bit about DevOps and quality in the DevOps world. But before we begin, we should probably level set and say what exactly is DevOps, right? Because if you ask 10 different people, you might get 20 different responses of what DevOps really is. So just so we are on the same page, let me give you Microsoft's definition of DevOps. So for us, DevOps is something very specific. It is the union of people, process, and products to enable the continuous delivery of value to our end users. Now notice I said that super, super carefully, right? One of the biggest reasons is the person that came up with this definition for Microsoft is literally my manager. So if I get this wrong, I'm kind of in big trouble, right? The other reason is because every word was picked very carefully. The main point is we need to be able to continuously deliver value to our end users, right? That's the key. We need to deliver value, not piles of code, because if we just deliver code, we have piles and piles of code, but what does it do? Absolutely nothing, right? That's not delivering any value. We need to deliver value. We can't even deliver millions of features, feature after feature, because if those features are not what our end users need or want, why are we even doing this, right? So we need to be continuously delivering value. But the big key is, it's kind of difficult to do this, so why is this even important? And the reason is, the speed of business is so incredibly fast today that if you don't adopt DevOps best practices, guess what? Your competitors, they're either doing this or they're going to do this. And as soon as they do, they're going to be moving so quickly that they will out-innovate you. And once they out-innovate you, guess what happens to us? We become obsolete, and nobody wants to be obsolete, right? So this right here is no longer just theory. DevOps has been a thing for long enough now that we absolutely empirically know this to be true. Teams that use DevOps best practices absolutely innovate so much faster, right? So this is important, but it is also very difficult to do correctly. And what we've noticed when at Microsoft we made this DevOps transformation is that we had to address all 3 of these pillars: the people, the process, and the products that we use to enable all of this. Now, the people portion, this is probably the most difficult part to change in an organization, right? Basically, we're talking about the culture of your org. The culture needs to be where from top all the way down to the bottom, everybody is aligned and hyper-focused on continuously delivering value, whatever that takes, right? So this requires a cultural change. It is kind of difficult to do, but is absolutely vital. Next, we need to have a process that actually makes sense, right? So we need a process that will let us iterate fast enough, yet still deliver code of high enough quality. So we need to have a process, things like Agile and Scrum, they work incredibly well because it lets us plan from sprint to sprint. It lets us, check in our code in and out, and as we're checking it in, we can track it against the work. And once we check code in, automation needs to be kicked into place where builds automatically kick off. Unit tests are automatically run. And code, if everything looks good and quality is good enough somehow, those bits need to automatically get picked up and deployed into our dev environment, QA, all the way out even into our production environment, right? But once it hits production, it doesn't end there because we still need to be able to monitor our application to figure out what are people doing in our application? What are they doing? Is my app performing well? Is my app even up or down, right? Those are the type of questions that we need to figure out, are we delivering value? And if we are, hooray for that, let's double down on the next sprint. And if we're not, let's course correct so we can start delivering more value, right? Now, to do all of this, it's kind of difficult, and we need to have the right set of products that will help enable DevOps best practices. So we need products that will help us plan and track our work from sprint to sprint to sprint. We need to have dev tools, right, where we can check our code in and out of version control systems. We need to be able to write unit tests. We need to be able to check in our code and automatic builds kick off that run these unit tests. We need to have automation that will pick up all these bits and start deploying them into our environments, dev, QA, all the way out into production. And in production, we need to be able to monitor what our users are doing so that we can learn, and on our next iteration, hopefully we can do better, right? And there are tools out there, all sorts of different tools and products that we partner with that you can absolutely use to get your code into Azure using DevOps best practices. Or you can also use our product, which is called Azure DevOps. I know it's kind of a weird name, but that's the product name that we have, that really enables everything that you see end to end. And we don't do it alone, we do it with all of our partners as well. So this is what we literally use at Microsoft to deliver Azure DevOps. So let me show you what I mean, right? So at Microsoft, Azure DevOps is a giant product. It's global, it's worldwide. And on top of that, it can never go down, right? It's a service. So we use Azure DevOps itself to plan, to build, and to release Azure DevOps in production. So there's some weird inception type stuff going on here, right? But it totally works, and we do this with no downtime. So let me show you guys an example of what I mean and how we use Azure DevOps. So let me go ahead and jump into my sample app. I have a pretty simple demo to show you guys that really kind of highlights how this tool helps us deliver our code really, really quickly in using DevOps best practices. So this is a typical web application, right? It's a health tracking application. It tracks the exercises that I do throughout the day. It even tracks the food that I eat throughout the day. And it gathers up all that information, draws some pretty graphs, and tells me if I'm healthy or not, right? So if you notice, I have a column here when I'm looking at the food that's looking for the food color, which is absolutely ridiculous. Who needs to track the color, right? So somebody flagged a bug on me, so now I need to go in and make the changes. But I need to change my web code and also my database schema to support this. So the first thing that I would do is I would jump into Azure DevOps, and if we go ahead and look at our boards, we have the ability to track any unit of work in a software project. So here's my bug. And usually what we end up doing is I go ahead and create a branch for myself to work in, and I do a pull request, right? But in order to save time, I'm just gonna go ahead and make my change directly in my code. So let's go ahead and bring up Visual Studio where I can make my changes. And the first thing I'm gonna do, remember, we have to change the database schema and also the web code. So let's go ahead and blow away this column in my database. And let's make some changes in my code, and I'll just comment this section out and comment this section out. another section, and one more. So now I've changed my database schema, and I've also changed my web code. So the next thing I need to do is I probably should check my code back in, right? So let me go ahead and jump here. I'm just using a Git repo. So let's check my Git status. And let's add all the changes in. Let's do a commit, demo code. And then let's go ahead and push those changes back into Azure DevOps. Now, as soon as code hits my repo, let's go ahead and jump back into Azure DevOps, and I'll show you what's actually happening now. So code has hit my repo, which means my build should be kicking off. So if I jump in here, you can see, aha, here's my demo code changes that I made, and the build has already kicked off. And of course, we can see in real time exactly what the build is doing. So while the build is running, let me show you exactly what's happening with this build pipeline, right? So the way the pipeline works in Azure DevOps is basically, it's a task runner where it runs one task after another, after another, after another. So literally what I'm doing is I'm restoring my packages from NuGet. I'm going to scan all of my code using white source to look for security flaws in any open source libraries that I'm using. I'm going to build my solution using Visual Studio, and then I'm going to go ahead and run all of my unit tests. And when that's done, and if everything looks good, let's go ahead and publish my symbols, let's copy all the build artifacts, and then we publish those build artifacts to my drop location, right? So this is fully customizable, where you can make this build pipeline do anything that you want it to do. So the way that you would customize it is by adding and removing tasks and dropping them where you need to, right? So out of the box, there are hundreds of tasks that you can use for any language, targeting any platform, right? I don't want you guys to think that this build system only works for .NET and Windows. No, it works for any language, targeting any platform. So of course, people ask me, great, you guys have hundreds of tools that you can use, but what if I want to do something in my build pipeline that doesn't exist out of the box, right? What I would do is I would check the marketplace, because in the marketplace, we have over 1,000 tasks that our partners have created that you can just download and start using. And as you scroll through this list, once again, you start realizing really quickly, any language targeting any platform. So of course, the million-dollar question is going to be, what if I want to do something in my build that doesn't exist out of the box and it's not in the marketplace? And it's still not a big deal, because guess what? You can write your own custom tasks. A custom task is nothing more than PowerShell or Node.js. So what that means is literally anything you can do from the command line, you can easily create custom tasks to do as well. Or translated another way, you can get this build and release system to do anything that you want it to do. All right, so let's go ahead and jump back to the build. It should be, if not done, near done, and it is done. You'll notice that we get a nice little summary report. It will be linked to any of the work items. You'll be able to see my test results, so all of my tests passed. You can even see code coverage. I only have 10.5% code coverage with my unit tests, so clearly I need to write better unit tests, right? All right, so you get this build report. It's really nice. You get your drop files as well. So this is your build artifacts, where you can see I have everything that I need, right? So here's my drop. I have, basically this is just all of my build artifacts, including all of my different template files and things like that. So notice that it's also been kicked off and it's going through our deployment pipeline as well. And I have a couple environments, because I have a dev environment, QA, Canary, and prod. So we'll go ahead and jump in here to see the release going on as well. So here's the release. It's actually happening live. So we can jump in here. And just like the build, we can go ahead and jump into the individual releases themselves to see exactly what's going on, right? So it looks like I already deployed into my dev environment, and it's waiting for me for an approver, right? So, but before we jump into that, let me show you how you can actually set up one of these pipelines. So the way that you set up a pipeline, first you describe what your environments are going to be, or what your stages are going to be. And I have a dev environment, QA, Canary, and a production environment. So you set up these environments, and after you decide what your environments are, you would jump into each individual environment, and now you would add the tasks that you would need to deploy your application into that particular environment. So in my case, I'm deploying my app into Azure App Service, and I'm going to deploy my database changes using a DACPAC task. Right? Once again, fully customizable. You can make this do anything, just like the build, by adding and removing tasks. Right? exactly like the build. You can customize this. You can use tasks from the marketplace. You can even write your own custom tasks as well. So literally you can deploy anywhere, including even into other people's cloud, although don't do that, use my cloud. No, I'm kidding. I mean, but literally our tool doesn't care, right? You can deploy, build whatever you want, deploy it anywhere that you want. All right, so after you define what your pipeline looks like, what the tasks are for each individual stage, you then get to decide, okay, I can add approvers before and after each environment as well. So approvers can be people, it can be a group of people, it can be a list of people. It can even be automation where you can add AI that can figure out if it can go from one environment to the next. So that's how you set it up. So if I go ahead and look at my release right now, and I look at my release pipeline, we've deployed into the dev environment, and now it's waiting for a person to approve, right? So if we go back in here, we refresh the screen, and it's going to take a while to refresh because it has to recompile everything really quickly on the server. But eventually it will come back, and you'll notice that the color column will be gone. If we go ahead and jump into the database itself, you'll be able to see that the database column was deleted as well, right? So this was a real deployment. So I can go ahead and say, yes, this looks good. I'm going to go ahead and approve it. Looks good in dev. And as soon as I approve it, it flows on over into the next stage, right? However, I've tightened down security a little bit. So instead of just blasting code into the next stage, I want a pre-deployment approver. So you don't have to have one, but for this demo, I wanted one, right? So I'm going to go ahead and approve this, and I can say this is ready to deploy. And here's the cool thing, right? If I click approve, immediately bits starts to flow. Or I can even say, yes, I do approve this change, but let's wait until, I don't know, 2 in the morning when nobody's on the system, right? So you can schedule when you want this to actually happen. But for this demo, we're just going to click approve, and immediately bits, they're going to start flowing now into the QA environment, right? So in this fashion, we can continue doing this, and eventually we can push our code all the way out into production like this with no downtime, right? So granted, this was a pretty simple demonstration, but it kind of just shows the power and flexibility of the tool set that we use, right? We can literally do whatever we want in our deployments. And our deployments are very, very complex, and of course, much more complex than just a little web app with a database. But we do the same type of principles, right? Where we deploy our code, we deploy our database changes, and throughout the entire thing, there is zero downtime that's going on. And if you notice, this is so incredibly simple that somebody that checks their code into the repo, that change can propagate and ripple and get deployed all the way out into production in minutes, right? So here is the million-dollar question for me. How do we maintain quality in a DevOps world, right? We have these amazing pipelines that will take our code checked into source control and push it all the way out into production. But how do you maintain quality? Because if you don't have quality checks, this awesome pipeline that we have, all it does is it allows us to push bugs into production at a super fast rate, right? And that's absolutely insane. We can't do this. So how can we possibly maintain quality? So how did we maintain quality before DevOps, right? The way that we did it at Microsoft is we would basically do end-to-end functional testing, manual functional testing. And this was pretty good. Basically, we'd wait until the end. We'd develop code forever, and then at the end, we would run all these test scripts and find a mountain of bugs, and then we'd spend forever trying to burn down this mountain of bugs, right? The problem with an approach like this, number one, is you will never be able to burn down that mountain of bugs completely. You've built up so much technical debt that it's impossible to burn through the entire thing, right? But hopefully you can get all the most important stuff burned down and your quality is good enough. But the other problem is this takes an incredibly long time to do, an incredibly long time. So for a big product, it can take months. For a massive product like, I don't know, say Windows or something like that, to run full functional end-to-end testing could take up to a year, right? I mean, we're talking massive amounts of testing effort. And in this new DevOps world, nobody has the time to do that anymore, right? Our pipelines get our code into production super fast. Our iterations are really fast. We're pushing code into production maybe, well, for us at Azure DevOps, we're pushing brand new features into production once every 3 weeks, like clockwork, right? For our bug fixes, we're literally pushing bug fixes 2 times a day, right? So if you're moving at that pace, how do you maintain quality? We can't do end-to-end functional testing. There's just not enough time. So what we did, and I'm not saying this is the only way to do things, but what we did is we shifted left, right? So we started putting the burden of quality onto the heads of our developers, which they absolutely hated. So the first thing that we tried to do is, you know what, why don't we just build automated UI tests for the entire functional test suite and then pray for that. Then we can just run the automation and maintain the automation. That's all we need to do. So we spent a huge effort and we did that. And that ended in a dismal failure because number one, the tests would run, but they would run for a really long time. But even that wasn't the worst part. The worst part was tests were extremely fragile, which meant it was very difficult for us to track. I mean, they were incredibly fragile. There were times when we could run the test, the entire test suite, and 3 tests would fail. We would run it exactly the same environment, just rerun them, and magically they'd be fixed, but a couple other ones turned red, right? So it got to the point where nobody paid attention to our tests because we didn't know, is it breaking just because the tests are weird, or is it breaking because we actually broke code, right? So that didn't work really well. So then the next approach that we did was, all right, let's make developers responsible. Let's shift our bulk of our effort away from functional testing and automated UI testing, and let's do things like unit testing. And this actually has worked out incredibly well for us, but not at first, right? So at first, people like me, a dev, I was extremely resistant to something like this. I was like, this is ridiculous. I write code. I am not good at writing tests. I am not a good tester. That's not what I do. That's not who I am. Microsoft said, too bad, make it happen, right? But in order to incentivize us to actually write good tests, what they had to do is they made us responsible for the quality, and they made us feel the pain of the bad code that we write. Because back in my day, and I'm pretty old, so back in my day, I would write code, throw it across the fence, QA, you know what, they can find my bugs. And usually, if I'm lucky enough, I can move on to something else, and somebody else has to actually go and fix my code for me, right? So I never had to feel the pain of my own bad code. But now, Microsoft is making sure that I feel the pain. And the way they do that is we're in feature teams of about 10 people. 2 people in the team, they are responsible for bug fixes that happen in sprint, right? Including service outages. Now remember, Azure DevOps, the product, it needs to be up 24/7. So if we have a service outage, that's a really huge deal. When that happens, whoever's on call, they will get that phone call at 2 in the morning if that's it. They have to join a call bridge. And on that bridge is our entire leadership chain, including Scott Gu. And from beginning to end, you are not allowed to leave that call until you figure out A, what's wrong, B, you fix it in production so that you mitigate the problem, and C, you have to go back, now fix it for real so that this problem will never happen. So you have to figure out what the root cause is. And when that's all done, now you can finally get off that call with all of the leadership breathing down your neck. Now, I don't know if y'all have been on a call bridge like that. That is the most miserable place to be ever. I've been on it once and I never want to do that again, right? So because of that, we as a team, we are very, very careful about the code that we write. We write incredibly good unit tests to make sure that we catch regressions and that these types of problems don't occur. And every developer check-in has to go through a pull request or code review. And as we're reviewing our code, we're not only reviewing the code, we're actually reviewing the unit tests as well. And this is so incredibly important. So just to give you guys a little bit of a scope of how intense our unit testing program is at Microsoft, let me show you in production what I mean. So here is my engineering dashboard, right? This is the little dashboard to my engineering work that I do at Microsoft. So don't look too closely because there may be stuff that I'm not supposed to show you guys. But what I wanted to show you was, let's go ahead and look at the pull requests that are floating through. Okay, cool. Here's a pull request that went through. Let me go ahead and click on it. So remember, every developer check-in has to go through a pull request. So in our pull request, you can see that 100% of our tests pass, and we had to run 84,000 697 unit tests. So let that sink into your brain for a second. Every developer check-in has to go through a pull request, and the first thing it does is it builds and it runs our fastest running unit tests, our tier 1 and tier 2. And it runs 84,697 unit tests. And that's just today. That number keeps on growing. Anytime somebody adds new features, guess what? They start writing more unit tests as well. This is how we are able to maintain quality in a DevOps world where we can push multiple times a day into production, right? The other thing that we do is we have a very heavy use of feature flags. And let me jump to the right slide. We use feature flags extensively. So any new feature that gets written is hidden behind a feature flag. So what this does is it helps us two things. Number one, it separates deployment of code from deploying a feature so that people can actually see it. It allows us to do things like testing in production. It allows us to roll back really quickly if things look bad by just turning the feature flag off, right? So there are a whole bunch of reasons why we would want to use feature flags and why feature flags are so important, right? And all of these bullet points, I actually have an hour-long talk that about each one of these specifically. But basically, these are things that we do at Microsoft to help ensure quality. Now, I know some of you might be thinking, okay, all the unit tests in the world, that's great, but you still need to have some type of integration tests, right? And at some point, you still have to have eyeballs look at, human eyeballs, look at the screen, right? Because sometimes the UI can be wonky, even though functionally everything is working perfectly, right? And at Microsoft, we 100% agree with this as well. So I did say we moved the bulk of our testing effort into unit testing instead of functional testing, but we still have the need for integration tests, and we still need to have eyeballs look at stuff, right? And this is where we wrote our automated UI testing. So now we're not trying to do, a year's worth of functional testing all in automation, but we have automated UI testing that does a lot of our integration tests for us. And the problem with having human eyeballs look at stuff was really not a problem, but once again, that kind of slows things down, right? Because a human has to check and run through the test script to make sure all the screens look good. But there's a really cool technology from Applitools, it's not even a Microsoft product, that really helps with this. It uses artificial intelligence, right, to do visual testing. So what that means is, and I'm sure Aaron can talk about this in a much better fashion, but basically, you write your automated UI test, and I write my test using Selenium, and you can use Applitools as well, where they can take pictures of your screen for you, and then they can do comparisons between what your baseline image should be and then what the image is for your latest code check-in, right? And it can flag those differences for you. Or if you want to keep those differences, you can say, you know what, this is correct, the change is correct, but let's go ahead and set that as my new baseline moving forward. Right? So you have the power to do that. And now what is so incredibly cool about this is you're shifting even left, right? Even your testing is being shifted left. Your manual or your automated UI testing is shifted left, where instead of needing human eyeballs all the time, you can use Applitools to act as your human eyeballs, and only if there's a difference, it will let you know, and then you can now decide, is this a change that I want? Or did somebody mess up my CSS file and now things look wonky, right? Or something like that. So it is super powerful and super useful. So what I want to do is show you just how easy it is to use Applitools and to integrate that into our Azure DevOps pipelines. All right, so first things first, I should go ahead and probably show you the code, right? So here's my code. This is my testing code. And so I'm using Selenium to write my tests. And when I write my automated UI test, I use a page object type of pattern where I create an object for every single page that my application has. And this page object, this object, is just a simple object, but it has all the actions that you can do on that particular screen. And it also has all the verifications that you can do on that screen. So for instance, actions would be like, oh, well, you can click on the exercise link, or maybe I can enter in text into this specific text box, right? So those are all the actions that you can do on that screen. And I also include the verifications that you can do. So maybe I can say, enter this text, click on next, and then there should be a text box that pops up or whatever, right? So I need to verify that that text box shows up. So I write Selenium code that can actually show me that as well. And the benefit of writing your test in this page object pattern is, number one, maintaining your code now becomes incredibly easy. Because the test is separated from the page logic. If my page changes, I just need to find my page object, jump into that page object and make those changes. So as you can see from my demo application, here are all my different page objects. So these are just the different pages within my application. So makes maintaining your automated UI tests so much easier. The other benefit is that my automated UI tests become incredibly easy to read as well. So for instance, here's my web app, and I'm going to go ahead and launch it. And I pass in the browser, which is going to be Chrome. And then let's go ahead and browse to the home page of the application. I pass in the URL. Then I verify my home page has been reached. I click on the nutrition link. I remove all the donuts from the fields. I create a new link. I verify the page has been reached. I add a donut in there. I verify that the donut shows up on the table, right? So even if you're not a coder, you can look at this and be like, oh, I know exactly what this test is doing, right? So it just makes for a very, very clean way to write your automated UI test. But I'm using Selenium to do my tests. So if we go ahead and jump into my launch code, you can see this is where I actually do my Selenium, right? So the first thing that I do is I check the browser. And if I pass in the correct browser, then it's Chrome, I create a Chrome driver. Then I launch the browser, I set the window size. And then the next thing that I do is I browse to my home page, right? So if I go to browse to my home page, I pass in a URL and I just say driver.navigate, go to the URL, and I return my home page and I pass in the driver, right? So this right here, this is just Selenium code. So if you know how to write Selenium, it's just Selenium. Let's see something else that I did as well. I can come in here and I can say, you know, click on the nutrition link. And if I click on the nutrition link, let me jump into that section of the code. Once again, I am just using Selenium to find the element, and then I click it, and then, you know, hooray for that. And I return back the nutrition page, page object that can do everything. So it makes for very, very clean tests, right? So now I have these tests. I want to add Applitools' ability to take pictures of my screens as I'm running through my tests so that it can compare future tests with my base images to make sure, you know, nothing has changed or things haven't turned wonky or weird with my UI from a visual perspective, right? It's actually super, super easy to add Applitools into your tests. If I go into my, what's the easiest way to show? Well, here we go. If you look at my tests now, there's a couple things that I need to gather before I even run. Number one is you have a specific Applitool key. So I do need to have that key. If I want to run my Applitool type stuff in my build and release pipeline in Azure DevOps, then I do need to grab a batch name and batch ID that automatically gets populated in my environmental variables as well, right? So I need to add that little chunk of code. And now let's go into my test. Let's go into, this is fine. Same thing, right? I launch my web app, and when I go ahead and launch the web app, let's take a look and see what that looks like. Same thing, I create a Chrome driver, but now I grab the batch name and the batch ID. I create an eyes object, which is part of the Applitools API, which you can just get from NuGet. And from here, this right here, yeah, this is the important code. I create my eyes object. I call eyes.open to set, you know, this is going to be my test. This is going to be my window size. And here I set my Chrome to the same window size as well. So the next thing I do is I browse to my home page, verify the home page has been reached, and then I have this method called take visual picture, right? So let's go ahead and drill and see what that means. When I take a visual picture, it's literally one line of code that I do. I said eyes.checkWindows, and of course I pass in a tag that will show me, oh, this just helps me organize stuff a little bit easier. So now what that does is on this particular page, Applitools will snap a screenshot, and it can set it as my baseline. Or I can set it as manually set it as a baseline, and then future tests, it will compare the pictures that it takes with the baseline to say, has anything changed? And if it has, is this a mistake? Or do you want to set your new changes as your new baseline, right? So super, super, super simple to do. So once I add this, let's go ahead and look at this test again, right? I can go ahead, browse to my home page, verify the home page has been reached. I take a picture, I click on the nutrition link, verify the nutrition page has been linked. And when I call verify, remember this is logically checking to see if the page has been reached. But then I take a picture of that page as well. So then if something looks wonky, even though if I'm on the right page, like for instance, the CSS got changed, not a big deal, because guess what? Applitools will flag you and let you know, right? Super powerful, super easy to use. The code changes that you make is almost nothing, right? So what does this look like? How do you set this up so it's automated in your build and release pipelines? Well, let me go ahead and jump and show you what that looks like. So if I'm using Azure DevOps, let me find the right browser. Here is my build pipeline. Oh, that's completely the wrong project. That's my real work. All right, here we go. Here's my build pipeline. And here's my Applitools build, and I'll go ahead and edit it to show you guys what that looks like. Now, this build should look incredibly similar to the previous build because it's literally the same thing, but I added a couple of stuff. So the first thing that I do is I added the Applitools build task, and you can get this build task from the marketplace. Right, you can add it into your marketplace, and I've already installed it, so I can now just drag and drop it wherever I need to. Add it right before you compile your application. Then I run my unit test, and then if everything looks good, I go ahead and deploy my application into a CI environment, and now I run my automated UI test using Selenium. And that is literally all I have to do. And when it runs, this is what my build will end up looking like. So here's my build. Let's go ahead and look at a good one. So how about fix my CSS error? All right, so we can come in here, we can look at the build summary, we can look and see that 100% of our test is passed. Hooray for that, that looks good. And if we look at the Applitools tab, you get a brand new Applitools tab now. It will actually show you all the pages that were done, everything looked good, everything is passed. And if you notice, if I click on these, you'll be able to see screenshots of every time I took a picture, right? Pretty cool, huh? All right, so what happens if something looks a little bit wonky, right? All right, so let's look at something wonky. Let's go ahead and look at this one. We'll go ahead and jump into my summary, and you'll notice here, only 90.9% of my test has passed, and 2 of them is in an other category. Well, that's weird. Which 2 are those? I can go ahead and take a look at those. Let me look at my others as well. And you'll notice 2 of my automated UI tests are returning back as inconclusive. So something weird is going on. And if I look at my Applitools, because that's where my automated UI tests are running, I'll notice that, ooh, when I go to my exercise page, things are starting to look weird, and it flagged it for me. And if I jump in here and actually take a look at this, you'll notice that the table is no longer nicely formatted. Somebody must have messed up the CSS, right? So logically, everything still works, but visually, it doesn't look good. But I didn't need a human to tell me that. Applitools actually told me. So now I can either say, you know what, this is the way I want it. I made that change specifically, so make that as my new baseline. I can do the thumbs up, or in this case, oh, something's not right. Let's go ahead and thumbs down it, right? So now it will mark these as failed, just like that. Now, future builds will be able to figure out what's going on. You can even set up things so that, you know, if you fail it, you can automatically create a bug and put that on the backlog as well to fix. But this right here makes me so incredibly happy because it's, number one, it's really powerful. It shifts automated UI testing even to the left, and it makes our pipelines go faster and smoother, right? Super cool, super, super useful. So I am not an Applitools expert, not even close to it. I'm just a code slinger. I ran into this tool set. It was freaking amazing how easy it was to use and how useful. But what I'm going to do is I'm going to turn it over to Aaron because he knows so much more about Applitools and he can kind of give a better overview of what this tool set can do. But this is cool stuff that integrates fully and completely into Azure DevOps. If you're not using Azure DevOps for your CI/CD pipelines, that's not a big deal either because I'm sure Applitools works with all sorts of tool sets as well. But what I do know is it works amazingly well with Azure DevOps. All right, thank you. Aaron?
Thanks, Abel. It's been a while since I had so much fun watching someone else demoing Applitools. And just for the protocol, I was trying to chase Abel for the past month and trying to offer my help setting up this demo, and he kept on refusing, saying, I'm good, I'm good. Now I see you were definitely good. So thank you so much, even for showing that it's that simple to get started. So let's, can everyone see my screen? Abel, do you see my screen?
Yes.
I'll take that as a yes. Okay, cool. So just a little bit about me. I've been a software engineer for over 20 years. I'm a multilingual engineer. I speak many languages out there. And my true passion is automation. This is why I think the combination of Applitools and what I love doing is perfect. And on top of that, the CI tool, the Azure DevOps tool here is also a perfect match to connecting all the dots. And the less human error prone it is, the better for me. Just to reiterate some of the things that Abel was mentioning, our mission basically here at Applitools is to ensure that your product is visually perfect and the user experience on every browser and every device is flawless. Now, in terms of where we are at today in the world of visual testing, there's still work to be done, and it happens to everyone. Here we see an example from Amazon on Prime Day, and forgive me, Abel, even your team with the Azure team here, sometimes there is a glitch. And these things are very hard to catch, like Abel mentioned, with functional testing. When you're querying the page and asking, is an element there, is it visible, you're not always asking the right questions. And this is where functional testing has a huge gap, and probably this is why Microsoft also shifted to left and try to give more responsibility to developers, because the fact that the functional test passes, it doesn't mean that our product looks great. So here are a few other examples: UPS, Twitter, and you're thinking all they had to do is have 250 characters to take care of, but it's always more complex. Financial Times, you see the title of this article breaks. So it happens to everyone, and our job is to help you guys avoid it. Now, our world as engineers is becoming more and more complex. We're breaking down our applications to microservices, but then we start to hit market, and our customers are using us over different OSs, different browsers, different devices, and this kind of matrix of our users is becoming a nightmare to cover in terms of tests. And even if we had our tests set up using automation tools like Selenium that Abel mentioned, it's still not enough, because you still need eyeballs to take care of that. And the way the flow of test automation looks something like that. We have a product change, we run the tests, we analyze the test failure, the test results or the test failures, and then we either report bugs or fix broken tests. And then going back and forth. Now, if we want to see where testers spend most of the time, it's right in this area right here, where they're busy analyzing their failures and fix broken tests. And this is why Abel chose to use page objects, because this is a more robust way to set up your tests. So even if they break, it's easier for you to fix them. QA reporting back is also a challenge. It's also a bottleneck. You don't always have all the information to give back, or it's hard to reproduce, and then the engineer needs to spend time recovering or reproducing the environment that the tester was running on, and trying to figure out what happened during the time of the test. Now, the challenge here is that by the time the engineer who wrote the code gets the bug report, he or she is already working on a different feature branch. So they have to stop their work, go back in time, and dig through their Git repository to find exactly what went wrong. And that's always literally a time waste. Now, I want to jump into the dashboard here and look at a few examples. Abel showed you the integration within the pipelines and how to set up the test, so that's perfect. I do want to talk about kind of different algorithms that the AI uses to identify bugs in the system or mismatches. It's not necessarily a bug, it could be like an intentional change. So in this example here, we can see that we have a super dynamic page with the content that's constantly changing every time you refresh it. And in order to compare it using traditional visual testing tools, you will use pixel-to-pixel algorithm. However, pixel-to-pixel will fail the entire page because everything is different all the way from the top stories to the ad at the bottom right to the main stories, and unfortunately, even the logo. And that is because, let me remove the highlights and let me put them one on top of the other. And this is because pixel-to-pixel is sensitive to one pixel shift. And images will render differently based on different browsers, different devices, different operating systems. So this is not a reliable tool that offers a lot of false positives. But if we want to start using the AI here, we can use one of three algorithms we have here. The strict is the first one, which emulates a human, exactly what Abel was trying to achieve with his test. I want to make sure a human is looking at the page and telling me what's broken or what's wrong here. So here we see that a person would definitely identify that all these elements are different, but the top elements that have a minor pixel shift, that human would flag it as a pass. And the next algorithm is called layout, which the AI reverse engineers the page and analyzes the relationships between the elements and identify if anything is broken. So it's not looking at the content, ignoring text, ignoring images. So in this example here, we see that this is a match because the page is not broken. Now let's see an example where a page can be broken. And this is one of them. So in the baseline, we can see that all the text should be aligned right next to the logo, right? This is a mobile application, and we're trying to validate that it's still it's not broken between releases. Let me put them one next to another, and we can see that in the checkpoint, we see that the text broke right under the logo, and this is flagged as a mismatch. And there is another missing logo at the bottom by TechCrunch. Now, to see how cool it is, I'm going to put them one on top of the other and toggle, and you can see that everything is different in that test, in that checkpoint, because the tweets keep on shifting as the Twitter feed keeps on growing with time. So getting to that specific screenshot or timestamp, that's impossible. But using the layout algorithm, that's actually something that we can achieve easily. I'll show you one more example before we'll head out to questions. Let's look at this cool example. Sometimes one algorithm is not good for all cases, and we need to mix and match. And for that, we have our regions, where you can define different algorithms on different parts of the screenshot. And in this example, this customer wanted to test their application using strict. However, they're using data here, and data basically is something that's hard to test with strict because we're trying to validate that it looks the same. So we'll have to add layout region algorithms right here around wherever we have data that will change. So I can add a layout around this guy and layout right here. And we can add another layout around this element. And as I'm adding them, you can see that they're disappearing, except for one highlighted element that's still highlighted even within the layout. So let me put them one next to another, and I can see that in the checkpoint, this one actually is flagged as a mismatch. So we have a missing element, and that takes us to another region called the bug region, and I can report back missing value in span, for example, and report back. So this, and again, there are many more examples we can show, but I want to leave some room for questions here. So let's bring this up. Here you can see all the resources that Abel was talking about. Getting started with Applitools, you simply go to tutorials, and like we mentioned earlier, we support pretty much every framework and every language under the sun. So you can start today. And Adi, do you see any questions in the questions panel?
Yeah, of course, I see quite a few. So we'll start from the top. So Abel, you talked about feel the pain of your bad code, and this is the next question is something that comes up quite a lot in our webinars, and people are asking, does feeling the pain of your bad code, does that mean that the developers are now testers, or should the testers become developers? What do you think about this changing ecosystem?
So what we did at Microsoft is not necessarily what everybody should do, right? Because we're a pretty unique type of organizations. And let me give you an example. All the developer type testing that I do in the world, like that, it really helps ensure the quality a lot, right? But the way that we deploy Azure DevOps is we deploy it, it slowly rolls out to the entire globe, right? And it rolls out into these, what we call rings. Ring 0 is literally our engineering team of over 1,000 people. We use Azure DevOps every single day of our life, right? As we write our code, which means we are our own testers. So we have that ability to not have a dedicated testing team, specifically because guess what? We deploy into Ring 0 first. We're going to find dog food our own product on a daily basis. We're going to find most of the bugs. We're going to shake out most of those bugs when it's sitting inside of Ring 0. So it sits and bakes inside of Ring 0 for about, I don't know, 2 or 3 days. And then after that, if everything still looks good, number one, by that I mean nobody has reported any type of errors, and also we're running automated telemetry, right? So performance is bad or exceptions are occurring or things like that. If too many of those are happening, it will automatically stop that release. But if everything looks good, then it flows on into the next ring, which I think is in South America, right? And then slowly it keeps on going from ring to ring to ring until eventually it reaches the entire United States. So we were able to not have any official QA testers, but not all organizations can do that because you still need humans at some point. But the same token, it is absolutely vital now that developers don't just say, oh, I just write code and that's all I do, I'm not a good tester. Quality, in a DevOps world, things are moving so quickly. Quality is everybody's responsibility, including the developer. So that's my answer.
Okay. Next question, also for Abel. At Microsoft, how do you define code coverage? What is your definition?
Code coverage is an interesting thing, right? Basically, we're looking at the lines of code that is touched by our unit tests. Code coverage is a double-edged sword to me, right? I love it and I hate it. I love it because it gives me a good indication of, okay, is our test, touching most of our code? What it doesn't tell me is if the tests are of good quality or not, right? But that's what our code reviews are for. That's what our pull requests are for. The other thing that code coverage lets us do is we're able to very quickly see, ooh, guess what? We're writing a lot more new code and we're not writing any tests for that. That's not bad. So let's try to get the code coverage number. Let's not let it go down. Let's try to either keep it the same or try to keep it go up. What I don't like seeing is when managers look at that and say, create an arbitrary, you must have 80% code coverage or you must have 90% code coverage. Because then all of a sudden you have people writing tests that mean absolutely nothing but touches every line of code, right? That's super simple to do. So it's just one number amongst a huge amounts of number that gives you just a tiny glimmer or a kind of a feel of what your quality is like, or what the state of your testing for your quality.
So next question is for Eran. What happens if a backend element changes but the visual does not? Will Applitools understand and pass the test?
So the answer is yes, it would pass the test because we're in the business of processing images and we don't look at the code behind.
So the next question is actually for Abel, but I think that Eran, you might have something to contribute as well on that one. So Abel, we saw that in the production environment you had 84,697 test cases. How much time does it take to execute them? And how do you ensure it gets executed in minimum amount of time for faster deployments?
All right, so that gets kicked off during our builds, right? Including all of our pull request builds. Those are our tier 0 and tier 1 tests, which is our fastest running tests. They're not integration tests at all, so they're just pure unit tests. It takes, we have a rule that we want all the tests to run within 8 minutes, right? For a while there, it jumped up to 20, and we were like, ooh, we either need to prune our tests a little bit, or maybe we need to update how we're writing them to make them run faster. Now, understand that we are highly parallelizing. I don't know if that's a word. I might be making a word up now, but we are highly running these tests in parallel. We're also using massive build machines with like a zillion cores to be able to pull something off like that. But for us, it's very, very much worth it. Like I said, the longest that I've seen has hit like 20 to 30 minutes per build.
So Eran, actually, people are asking about the length of execution of running UI tests, and how does Applitools handles long-running UI tests?
So we sit in your test framework, same as what Abel was showing within your Selenium code. So it depends on how long your test is set up to run for. But grabbing those screenshots doesn't add significant delay to it. And the processing is done on the server side. We just grab it locally and upload it. So you won't even feel a glitch there.
Great. So unfortunately, that's all the time that we have for today. I see a lot more questions, and we will try to answer the ones that we can via email after the session. I wanted to remind you two things. So first of all, the recording will be emailed to you by Monday. And I do see all the thank you notes that you're sending Abel and Eran, and I promise you that they will receive all of those after the session. I just didn't want to take up the time the limited time that we had for questions. So again, I want to thank everyone that joined us for this live webinar, and of course, thank our guest speakers, Abel Wang and Eran Bar-Lev. So thank you.
Thanks, Adi, and thanks everyone for joining, and huge thanks to Abel for taking the time to come here and show us Azure DevOps.
Thank you all.